All right, everybody, here we go. We are about to be blasted with angles here, so make sure you are ready to rock. First thing we're going to do is talk about how you name an angle. Now, if you have just a freestanding angle all by himself, you can name it 4 different ways if it has a number inside. Most important part about an angle is this piece. It's called the vertex. And that's where the angle makes a turn, okay? It's where it changes its directions. So we can call this angle B. We can just name it by its vertex. If there is a number inside of an angle, it's not always going to happen, but if there is a number inside of an angle, you can call it angle 1. The other way is you name it with 3 letters, and the second letter is always the vertex. It's where it makes its turn. So it's like I'm starting at A, and then I make a turn at B and I end at C. That's how you would name this angle. And you can also go the other way. So instead of starting at A, you start at C, but you still need to make your turn at B before you end up at A. That's how you name an angle when it stands all by itself. Now, in this next diagram, it's not that it's a lot different, except for the fact that you actually have 3 angles here. You have this top angle, you have the bottom angle, and you have the whole angle. So there are 3 different angles sitting there. So that just makes one of those previous options go away. So, and that option is, well, let's first try to name the top angle. The top angle is this one right here. So we can see clearly that we can call it angle 1. We could also call it angle starting at M, turning at A, and finishing at H. Or we can have angle ham. But you cannot call it angle A this time. And the reason why you can't use one letter is because if I said angle A, how do you know which one I'm talking about? Are you talking about the top angle with the vertex A, the bottom angle with vertex A, or the entire angle with vertex A? So if there are more than one angle at the same vertex, you cannot use one letter. You have to use either 3 letters or you have to use the number inside if there is one provided. Okay? Next topic is angle types. Types of angles. If it's less than 90 degrees, so if we think about a protractor here, 90 degrees would be halfway because a protractor is 180 degrees. A full circle is 360 degrees for the full circle, so half of it is 180. So if we are looking at what's known as an acute angle, it's going to be less than 90 degrees. So that blue arc would represent a 90-degree angle. If it's smaller than 90 degrees, it's acute. Obtuse is more than 90 degrees. So if you have a 90-degree angle, it's going to continue to go past 90 degrees. Okay, a 90-degree angle is called a right angle, which is always going to be represented by a little box, or we will tell you that it's 90 degrees, or you'll learn about perpendicular. And a straight angle is also known as a line, and it's a 180-degree angle. Okay? So those are your 4 different types of angles. Moving on to angle addition. Angle addition is not much different than segment addition. So if you remember segment addition, we just took 2 little pieces and we added them together to create a big piece. Well, that's what's happening with angle addition. We take one little angle, we add another little angle to it, and when you're all done adding those together, you have one big angle. Okay, so it's going to be very similar. I always use the phrase little piece plus little piece equals big piece with segment addition. Well, for angle addition, we can just say little angle plus little angle is equal to the big angle. And we could even kind of use segments just so you can see it. We have angle ABD plus angle DBC, which is equal to angle ABC. if you want to look at it in terms of segments, so you can see that you're still just adding two little pieces to create a big piece. So, to do this example, it says ABC, that's the big angle. Okay, ABC is the big angle. Anything with D in it is going to be a little angle. All you have to do is add the two pieces, the two little ones. So we have little angle, x plus 2, plus the other little angle, 2x plus 6, is equal to the big angle, ABC, which is 5x minus 2. From there, all you have to do is combine like terms and solve. So we have 3x plus 8 is equal to 5x minus 2. 10 is equal to 2x, so x is equal to 5. And then we just have to substitute it into angle ABD. So that would be our top angle here. So x is 5. So 5 plus 2 is 7 degrees. Angles are measured in degrees. Okay? Next one. We see that this is a little box. So we know that the big angle is 90 degrees. So to do this problem, all you have to do is add the two little angles. So x plus 30 plus 2x is equal to the big angle, 90. And then solve away. 3x plus 30 equals 90. 3x is equal to 60. So x is equal to 20. And that's it. So you get to try the last example on this page. Pause the video and see if you can think your way through that one. Did you get x equals 30? Because if you did it correctly. This is three different angles that make up a straight line, which is known as a straight angle, which is 180 degrees. So, all you had to do is add little piece, and another little piece. So add up three angles and set it equal to 180 degrees, and solve for x, and you get 30, and you're good to go. All right? One last topic for this set of notes, and we are good to go. And that's an angle bisector. Now, an angle bisector is basically the same thing as a midpoint of a segment. The only difference is an angle bisector cuts an angle in half, where a midpoint cuts a segment in half. So again, in a way, this is review. All you have to remember is that these angles have the same measure. So angle ABD and angle DBC are going to be the same. And that's because they are split by an angle bisector. Okay? So you can call this angle 3x plus 2. And we could just double that one or add the two together and say 6x plus 4 is equal to the big angle given as 7x minus 6. That'll give you x is equal to 10. And then you just have to go find DBC, which we know is 3x plus 2 because these angles have to be the same. So then the answer is 32 degrees. Now another symbol you need to get used to is these little markings. Whenever two angles have the same markings, and there's all kinds of different markings. You could have just single swoops. You can have a swoop with a tick mark on it. You can have double swoops, triple swoops, all sorts of different kinds of angle markings. That means if two angles have the same mark, it means they are congruent, also known as having the same measure. All right. Last problem is a little bit of a challenge problem because you have an x squared. Now we've done x squared so far. So this one, although it might be a little bit more challenging, I would like you to pause the video, try this one on your own. You are solving for x and then finding the measure of angle ABD. Keep in mind BD is an angle bisector. So you do know that the little angles have to be equal to each other, if that is a little hint to help you solve this equation. The fun part about this is the factoring aspect. All right, pause the video, give this a try, and then we'll go over it together, and you are done. If you got 12 and negative 2, you have solved this correctly. But I want to go over this last step with you in detail one more time. When you get done factoring, sometimes you actually will have two answers that work out to be true in a problem. So anytime you see a negative, you don't get excited and say, oh man, I don't like negatives, and just cross them off. Sometimes the negative works. Sometimes the positive doesn't work. So you've got to always check. So what you do is you take your answers and you check them in the problem. But you have to check them in all angles that apply. So x is equal to 12. So we have 12 squared, which is 144, plus 2 times 12, which is 24, and you get 168 degrees. So that is a true statement. That is allowed to happen. The next thing you do is check it in here just to make sure. So 12 times 12 is 144, plus 24, so it works. Now you try the negative 2. Negative 2 squared is 4, plus 2 times a negative 2 is a negative 4, so you have a 0-degree angle. We cannot have a 0-degree angle because 0 and another 0, because this would be negative 24 and 24, that's like saying this angle doesn't even exist. So if it's 0 or a negative angle, it does not work. So your only answer for this is 12 and 168 degrees. Now, one little thing about 168 degrees. In this class, diagrams are never drawn to scale, or shall I say, rarely drawn to scale. So I know this says 168 degrees, which is an obtuse angle, and this looks like an acute angle. A lot of times that will happen in this class. Sometimes we'll draw an obtuse angle and it ends up being 3 degrees. Because we don't want you to be fooled by the picture. We want you to work with the math and understand the concept. Okay? That's it for this video. This is Longo and I'm out. See you. Bye.